All right, this is a lesson on graphing logarithmic functions. So this first slide is showing you a logarithmic and exponential function on the same coordinate plane. So in the blue here is an exponential function, and the base is greater than 1. On the second graph, here is your exponential function, but the base is greater than 0 and less than 1, so a fraction or decimal. If we want to find the inverse of the exponential, it's called a logarithm. And it has the same base. And what happens, in order to graph them, we interchange the x and the y coordinates. And then they are always symmetric about the line y equals x. So these are the characteristics of a logarithm. Please pause and read them. So the domain of a logarithm is greater than 0 to infinity. The range is all real numbers. A graph for a logarithm runs through the point 1, 0 and has no y-intercept. If the b value in the logarithm is greater than 1, it goes up to the right and is increasing. If the b value, the base, is a fraction or a decimal, that logarithm is going to go down to the right and it's a decreasing function. And the last thing is as x approaches, does not touch the y-axis. So that means there's a vertical asymptote at x equals 0. So here are the steps to graph a logarithm. Step 1 is you want to graph the inverse function, which is exponential. Then you interchange the ordered pairs of this exponential to create your logarithm. So here's our example. So first we're going to graph the exponential function of base 4. So we've done this in a previous lesson. So I'm just going to go ahead and evaluate the function for 0. So 4 to the 0 power is 1. I'm going to substitute 1 in. 4 to the 1 power is 4. If I substitute 2 in, 4 squared is 16. Negative 1, 4 to the negative 1 power is 1/4. So I'm just going to graph 3 ordered pairs. So the first order pair is over 0, up 1, which is your y-intercept, and then over 1, up 4, and then left 1, up 1/4. So here is your exponential function of base 4. To find the logarithm of base 4, we just take these ordered pairs and interchange them. So 1, 0, 4, 1, negative 1, 1/4. And now we graph them. So the first order pair 1, 0 is right 1, up 0. The next one is right 4, up 1. And the last one is 1/4, down 1. So the blue function is our logarithm of base 4. This yellow line that I'm graphing right here, it's a large line, it is your line that it's symmetric about, y equals x. So if you imagine folding your piece of paper along that yellow line, the red and the blue would match up. So let's identify some important pieces with the exponential function in red. So the exponential function, the domain is all real numbers. The range, there is a horizontal asymptote at y equals 0. So that means your range of values is going to be above that imaginary line. And then there's an intercept at 0, 1. For the blue function, which is your logarithm of base 4, your domain, I'm just going to erase this yellow line now. The domain is going to be everything to the right of this vertical asymptote. So you have a vertical asymptote at x equals 0. So then your domain is everything to the right of that or greater than 0. Your range is now your flip-flop of your inverse function, and then your intercept now is on the x-axis 1, 0. So notice the difference between these two pieces of value. They have a lot of similarities. And that's how you can graph an exponential function and a logarithmic function by hand.